My name is Jessica John Britto. My roll number is 20PH20014. My section is 20. For the DIY assignment number 2, I have made my project on Tinkercad on fire alarm. In this project, I have mainly used two sensors, temperature and the gas sensor. And to make use of them, I had to know their pin configurations. And since in this case I have used TMP36 as the temperature sensor, and here is the pin configuration of the TMP36, and I have made use of this to make the connections to the Arduino board. And the analog pin is A0, and I have done the same thing to the gas sensor as well, but the analog pin is connected to the A1. And as you could see here, I have used many variables, and these are mainly used in calculating temp. And I have assigned the green pin of the LED to the 13th digital pin, the blue pin to the 12th, the red pin to the 11th, the piezo pin to the 7th. And um, and I have made all of these four pins as output. And now I'm going to explain uh, at how I arrived at this equation, the relation between temp and stemp. I have assigned stemp to store the values read from the pin A0, and we know analog read can give a range of output of input from 0 to 1023. And we know that 0 corresponds to the minimum voltage, that is 0 volts in this case, and 1023 to the maximum voltage, and that is 5000 MV. And MV per division is 5000 minus 0.1023 minus 0, which is 4.88 MV per division, which is approximately 5. In our case, uh, the multimeter connected across the terminals of the temperature sensor, the minimum is minus 40 degrees Celsius, and it corresponds to a voltage of 99.9 MV, and the corresponding STEM is 20, and the maximum voltage it can have is 1.75, and it corresponds to a temperature of 125 degrees Celsius, and it corresponds to 358 STEM. I have assumed the relation between temp and MV as a linear one, and have assumed temp to be along the y-axis and MV to be along the x-axis. And on substituting the minimum and the maximum values in this equation, we get the values of C, which is minus 50, and M as 1 upon 10. And finally, we get temp is equals to V upon 10 minus 50, where V is in millivolts and temperature is in degrees. And also we know that V is 4.88 times of stem. So temp is stem into 4.88 upon 10 minus 50. So, and this is what I have used here. I have replaced stem into 4.88 by vtemp here. So this is how I have managed to convert the temperature to degrees. As you could see here, I have set the temperature against 125 degrees, and it displays 124 approximately. And I have divided this project into four scenarios. The first scenario is when the temperature rapidly increases by 5 or more degrees and the temperature is less than 50 degrees. So in that case, we get a yellow light from the LED, as you can see here now. And second case is when the temperature is below 40 degrees. And in that case, we get a green light from the LED. And the third case is when the temperature is more than or equal to 40 degrees, and we get a red light from the LED. And the fourth case is when the smoke sensor has a reading more than or equal to 100. And in this case, um, we'll get a buzz sound from the buzzer, and it emits a sound at 800 megahertz for 800 milliseconds, and after delay of 200, it emits sound at 600 megahertz at 800 for 800 milliseconds. And also we get the red light from the LED. And here what is, and you can observe the change here. Here is the code that I used on Tinkercad, and now I'm going to compile it, and it says done compiling. I believe there are no errors in it, and I hope you have enjoyed watching this video, and thank you for investing your time into this.